Welcome to Mrs. Neller's notes for her double block algebra class. These are the notes for section 3.2 entitled Solving Equations Using Multiplication and Division. And our goals for today are to solve one-step linear equations using multiplication, to solve one-step linear equations using division, and to write and solve one-step linear equations that model a word problem. So just like the previous lesson, when we're solving equations, or algebraic equations, we're going to use inverse operations. And again, those are operations that undo each other. So today we're going to focus on the opposite of multiplication and the opposite of division, or the inverse of multiplication and the inverse of division. So the inverse of multiplication is division, and the inverse of division is multiplication. So when we have an equation that has multiplication in it that we want to undo, we're going to divide. When we see an equation that has division in it and we want to undo that division, we're going to multiply. And remember, we have to isolate the variable still. And isolate means that we have to get it by itself. And then we want to keep the equations balanced. So what we do to one side of the equation, we're going to have to do to the other side. So in example 1 here, we have 4 parts, A through D. And we're just going to practice solving one-step equations that have multiplication or division in them. And we have to show our work. Again, we want to show our work now when there's an easy 1 or 2-step process. Later we're going to have equations that have 8 steps in them. So you want to make sure you get really good at showing your work now so that you're really good at it later too. So in part A here we have 3 times x equals 18. And again, if you want to isolate your variable, if you want to box it so that you know where the variable is and you know what you need to do to isolate it, that's great. You don't have to box in the variable. But since we have 3 times x equals 18, or 3 times something, we want to undo that timesing. So we're going to divide both sides of the equation by 3. So now 3 divided by 3 is 1. That cancels out. And 18 divided by 3 is 6. And again, we could double check our work. We could substitute the 6 back in. 3 times 6 is 18. And for part B, here again we have another multiplication problem. We have 3 equals negative 5 times x. So if I want to box in that x so I know what I'm solving for, I can. The x is being multiplied by a negative 5, so I have to undo that multiplication. So I'm going to divide by a negative 5. And what I do to one side, I have to do to the other. So positive 3 divided by negative 5, that's just going to be 3 over negative 5. But I don't like to leave the negative in the denominator, so I'm going to bring the denominator up front, or even leave him out front. So it's going to be negative 3/5. And then the negative and the negative 5 and the negative 5, they're going to cancel. So I get x. Now x is solved for. Now you can leave your answer as a fraction. That's fine to get a fraction for an answer. Just make sure you reduce it. We can't reduce 3/5 anymore, so that problem is solved. Now C and D both have division in them. In part C we have r divided by negative 5 equals 20. So again, I'm trying to solve for this r. R is being divided by negative 5, so I'm going to do the opposite of that. I'm going to times by a negative 5 on both sides of my equation. And then that multiplying by negative 5 and dividing by negative 5, they're going to cancel. So then 20 times 5 is 100, and positive times negative will be negative 100. And again, we could double check our work. Negative 100 divided by negative 5. 100 divided by 5 is 20, and then negative divided by negative is a positive. So negative 100 divided by negative 5 is a positive 20. Now part D, the variable is written on the right side this time instead of on the left side like it was in C. But in part D we have negative 3/8 equals n over 4. So I'm going to box in that n. And n is being divided by 4. So that's what I have to undo. I have to do my inverse operation. The inverse of dividing is multiplying. So I'm going to multiply by 4. I'm going to rewrite this down below just a little bit so I can see it clearer. I have 4, and I'm going to put the 4 over a 1 times negative 3 over 8. Now here, I could put the 4 over a 1 here as well, but really that 4 and 4, they just cancel. Dividing by 4, multiplying by 4, they cancel. So it's all going to be equal to n. So now basically I'm multiplying two fractions. And we could multiply across, or we could cancel a little bit. If I multiply across, I'm going to get negative 12 over 8, and then I have to reduce that. If I cancel, let's see, 4 goes into 8 2 times. So n will be negative 3 over 2 when I multiply straight across. And we want to rewrite that as a mixed number, negative 1 and 1/2. So that problem had a little bit of review of fractions. Some of these problems have had review of positive and negative number properties as well. So now we're going to move on to a problem about division. But we have to remember that we never divide by a fraction. We always multiply by the reciprocal. So we're still going to do that here for these problems. We're still going to multiply by the reciprocal. So in example 2, we have 3 parts, A, B, and C. In part A, we have 3/8 times t equals 6. So again, if I want to box in the t so I know where my variable is that I need to isolate, that's fine. Now, t is being multiplied by 3/8. So the opposite of multiplication is division, but I'd have to divide by 3/8. And I don't want to divide by that fraction. So I'm actually going to multiply by the reciprocal. So I'm going to multiply both sides by 8 over 3. And I can put that 6 over a 1. Now here on the left side, if I multiplied 8 times 3 and 3 times 8, that's 24 over 24. That's a 1. So really, those cancel each other out. That's how I get t by itself. Now here, I could multiply straight across. I could do 6 times 8, which is 48, divided by 3 is 16. Or I could cancel, and I'll rewrite it to show that canceling work. 3 goes into the 6 2 times, and then 8 times 2 is 16. Okay, now part B says 4 equals negative 2/3 times x. So again, I'm still trying to isolate the x. It's being multiplied by a fraction. Opposite of multiplying is dividing, but I don't want to divide by a fraction. So I'm going to multiply by the reciprocal. And my reciprocal here is going to be a negative 3/2. I have to take the negative with the number as well. So I'm going to multiply the 4 by a negative 3/2. So again, the 3/2 and the 2/3, they're going to cancel each other out. Negative times negative makes a positive. So then I have negative 3/2 times 4 over 1. So here I could multiply across and say negative 12 over 2, which is negative 6. Or I could cancel. The 2 goes into the 4 2 times, and then I just get negative 6. So x equals negative 6. Now, part C, we really don't have to do the math here. Hopefully you know this. 4/5 of something is 0. 4/5 times t is 0. Hopefully you know that if the answer is 0, you know that t is going to be 0. Okay, so we should be able to work through this one mentally, but we can still use our proper algebra here. We can do the inverse operation. Instead of dividing by 4/5, I'm going to multiply by the reciprocal. I'm going to multiply by 5 over 4, and that's going to cancel out everything there. But 0 times anything is just 0. So even if you know, hey, if I'm taking a number times something and the answer is 0, that number, that something has to be 0. That's fine. You can just go right to t equals 0. If you need to show your work and reason your way through it, that's fine too. And then for example 3, we have our word problem. So suppose you drive 630 miles from St. Louis, Missouri to Dallas, Texas in 10.5 hours. Write an equation to find your average speed, and then solve the equation. Now, the lucky thing about this problem is that we already have an equation for it. We've got a distance of 360 miles, and we have a time of 10.5 hours. And we're trying to find our speed. Remember, speed is just a fancy word for rate. So we're really using distance equals rate times time, which is a formula we already know. I'm going to substitute in what I am told. I'm told the distance is 360. I'm trying to find the rate. I'm told my time is 10.5. So there's the equation now that I have to solve for. And the way to solve this is to divide both sides by 10.5. If I'm trying to solve for the rate, I have to divide by the number that's attached to it. So 630 divided by 10.5 will get me a rate of 60 miles per hour. I want to make sure you label it. Okay. So sometimes for the word problems, you will know the equation. Sometimes you might have to translate the sentences and make your own equation. But for tonight's homework, those word problems should be simple one-step multiplication or division equations that you're writing. So there are your practice problems for tonight. And if you have any questions, stop by and see me.